In this example, we have 5x to the 4 minus 22x squared plus 8 equal to 0. Now, this one looks very similar to a quadratic equation, meaning that we could just factor like any typical trinomial, but the issue is we have x to the 4th and x squared. So since the first term is x to the 4th and the middle term is x squared, we can't really factor just like a trinomial. The ones that we have factored in trinomials was because the leading term was x squared while the middle term was x. So one thing I noticed is that there's a common thing between x to the 4th and x squared. The exponent is even. So what we can do is substitution for the x's. So if I were to substitute x squared with x, then I could do the same thing with x to the 4th. Now, if we say that x squared is x, if I square the left side, that means I'm also squaring the right side. Again, I'm going off from this part right here. So x squared to the second power is simply x to the 4th equal x that is raised to the second power is just x squared. So basically, I can substitute x squared with x and x to the 4th with x squared. So if I do that, I'm going to have, instead of 5x to the 4th, I will have 5x squared. And then instead of minus 22x squared, I'm going to have minus 22x and then plus 8. Again, I'm only substituting the x squared and the x to the 4th. I didn't mess with the 5, nor the 22, nor the 8. So again, if I say that I can substitute x squared with x, sure, we could do that. Now to go from x squared to x to the 4th, I raise it by the second power. Since I raised the left side by the second power, I'm also raising the right side by the second power, which hence I got x squared. Therefore, I can substitute x to the 4th equal, or substitute x to the 4th with x squared. Now, once you do this substitution, you have to bring it back after you get in fractal form. So these two doesn't go away. They still here. Now, the purpose of this is that we got into a quadratic equation, a trinomial, a typical trinomial that we can factor. So my a value is 5, my b value is negative 22, and my c value is 8. So again, top is a times c, bottom is b. So a times c, 5 times 8 is 40. My b value is negative 22. Alright, so two numbers that you can multiply into positive 40, but the sum and difference is negative 2. Well, the only two numbers that fit that description, or the two criteria, is negative 20 and negative 2. These two will multiply into positive 40, but while I combine them, will be negative 22. So let me add the x's because we're going to have to factor this by grouping, since my a value is not positive 1. So I'm going to rewrite it as 5x squared minus 20x and then minus 2 and then plus 8 equal to 0. Alright, so factor this by grouping. My left side, the only thing in common between these two terms is 5 and x. So I'm going to divide both terms by 5x. So I'm going to have that on the outside. 5x squared divided by 5x is x. Negative 20x divided by 5x will be minus 4. And then on the right side, so what's in common between these two terms is the 2, because they're both even. Since the first term on the right side is negative, I'm going to write negative 2. So I'm going to be dividing both terms by -2. So -2 here. -2x divided by -2 is positive x. Positive a divided by -2 is -4. Alright, since the expression inside the parentheses are exactly the same number, same sign, I'm going to group them together. Meaning I'm going to group my GCF, 5x minus 2, together. And then the x minus 4 will be together. Now, here, I'm not going to set each factors equal to 0 and solving. I had to bring back what we did in the beginning, the substitution. So for every x that I have, I'm going to replace it with my x squared. So I'm bringing it back. So instead of x, I'm going to have 5x squared minus 2. And over here, instead of x, I'm going to have x squared minus 4. So I brought back everything that were x with x squared. Now what I just noticed that x squared minus 4, that is a difference of square. So I can actually continue factoring x squared minus 4. So if I do that, this one will stay the same because there's nothing I can do about this. So for x squared minus 4, I can factor as x minus 2 and x plus 2, because again, x squared minus 4 is a difference of square, and then this is a rule on how to get the factors. Now I just finished factoring completely, so what I'm going to do is I'm going to set each factor equal to 0. So 5x squared minus 2 equal to 0. Here, x minus 2 equal to 0, and then x plus 2 equal to 0. So for x minus 2, I'm just going to add 2 on both sides. So x equals positive 2. The last one right here, I'm going to subtract 2 on both sides. So this one, x equals negative 2. Now, the one over here, what I'm going to do differently is because we have 5x squared minus 2. First, I'm going to add 2 to both sides. We have 5x squared equal to 2. Then I'm going to divide both sides by 5. So I'm running out of space, I'm moving up a little bit. So it's x squared equal to 5 half. Now, this one, since it's x squared, so in order to get rid of the square right here, I got to do the opposite, which is the square root. So since I'm solving it, that means that it's going to be x equals plus and minus the square root of 2 over 5. Now the issue with this one is we got to be very careful because we have a fraction. Now if it was just a whole number, we're fine. Since this is a fraction, I cannot have a radical in the denominator. So I'm going to use this space to simplify x equals positive or negative square root of 2 over 5. And the reason I included the plus and minus in front of the square root is when we're solving and you're doing the square root, we're going to have two answers. So for example, the square root of 16, instead of just a regular 4, you can also do negative 4, because we know that 4 squared is 16, while negative 4 squared also give you the same answer, 16. So that's why when we do the square root of a number and we're solving, we include plus and minus in front of the square root. So what I'm going to do is simplify. Since it's a fraction, you can rewrite it as plus and minus square root of 2 over the square root of 5. So what I'm going to do is I'm going to rationalize the denominator so that I don't have a radical. I'm going to multiply by square root of 5 to the top and bottom. So when I do that, so on the top when I'm multiplying with radicals, it's going to be plus and minus. Square root of 2 times square root of 5 will be square root of 10, just like that. And on the bottom, square root of 5 times square root of 5 will be square root of 25. And then you can do the square root of 25, which will be plus and minus square root of 10 on the top because I can't simplify, but in the denominator, square root of 25 is just 5. So I don't have the radical in the denominator anymore, so I'm good right here. So my final answer is going to be actually not just 3, but 4, because the plus and minus count as 2 answers. So my answer will be x equal to 2, x equal to negative 2, and then x equals plus and minus square root of 10 over 5. So those are our answers. So we have to be very careful if we're doing the square root of a fraction, meaning that we can't have a radical in the denominator. So you just follow this process on how to rationalize the denominator. So I basically multiply the numerator and denominator by what we have in the denominator, square root of 5. Because if you look at the denominator, square root of 5 times square root of 5 will give you square root of 25. And you can definitely do the square root of 25, which is just 5. When you're multiplying with radicals, I just basically multiply outside with outside, inside with inside. Outside is just an invisible 1. So basically, 1 times 1 is just 1. That's why we just have that invisible 1 here, or it looks like there's no numbers outside. Now, if you have any questions, I would recommend that you practice on rationalizing the denominator when we're doing the square root of a fraction. If it's just a whole number, then you're just fine. You don't have to worry about any other extra step. It's just this.